Good morning, children. Let us continue with the synopsis of haloalkanes and haloarenes. Haloalkanes and haloarenes. Synopsis, let us continue, children. I hope yesterday's synopsis is clear to you. Yesterday we have discussed brief idea about why we are going to study the topic and how we are going to classify based upon different subclasses. Even we have discussed examples also. Now the remaining left, what is the topic is left out now. We need to discuss related with nomenclature, isomerism, and how does the nature of CX bond are going to become polar. On what electronic effect and how does the electronegativity can affect over there. Other than that, general method of preparation and as well as physical properties and chemical properties. Let us move to nomenclature. Let us move to today's topic, nomenclature. Nomenclature. And as you know, it is you have studied even in the first year that according to the nomenclature, that is the two systems are there to name the organic compound. One is called as a common system and another one is IUPAC system. One is common system and another one is what, children? IUPAC system. IUPAC system. According to common system, haloalkanes are, like is haloalkane, first one it is called as alkyl halide. Alkyl halide, and this is haloalkane. IUPAC is what? Haloalkanes. Haloalkanes. That means that alkyl halide. Alkyl halide is the common name which is derived from alkyl group. Yesterday what I said that from methane by removing one hydrogen will get methyl. Means methane converted to methyl by removing one hydrogen atom. Same way, ethane to ethyl, ethane to ethyl, ethane to ethyl, propane to propyl, maybe normal propyl, maybe isopropyl. So in general, we can say that from alkane, one of the hydrogen atom is removed. When one of the hydrogen atom is removed, those are called as alkyl. They are called as what, children? Alkane to alkyl. Alkane to alkyl. But according to what we said that according to the common system, alkyl halide. Alkyl halide we said. For example, to this alkyl group, that is methyl group, if Cl is present, it is called as methyl chloride. Methyl chloride. We can call it as what? Methyl chloride. If we are going to the example like CH3, CH, Br, CH3. All these are related with what, children? Common system. So what we said that CH3, CH, Br, we have called it as isopropyl. Isopropyl bromide. Because in NCERT they have given many of the examples. Even in the while going for the exercise, we will see all those questions based upon IUPAC system. Remember one thing, common system, as we said that isopropyl, iso is this one. CH3, CH, CH3 are called as iso. That's why we can call it as isopropyl bromide. If I am going with respect to what? CH3, CH, CH3, CH2, Br. Remember one thing, children, this group is called as iso group. This group is iso. Okay? This group is iso. But here, in iso, we are having 3 carbon atoms. One more carbon atom is present over there. That is CH2Br. We can call it as isobutyl bromide. What we can call isobutyl bromide. Remember one thing, most of the children will get confused over there between iso and secondary. If I am going to write secondary, how we can write? CH3, CH, CH2, CH3, Br. Okay, this is called as secondary. This is secondary. That's why I have made round over here with a different color. Remember one thing, CH3, CH, CH3 is iso. CH3, CH, CH2, CH3 is what children? Secondary. Secondary. How many carbon atoms are there? 4 carbon atoms. That's why it is called as secondary butyl bromide. Secondary butyl bromide. If someone will ask you why it is called as secondary, why it is called as secondary? As we know very well that carbon containing halide, this carbon containing halide linked with 2 carbon atoms. That's why it is called as secondary. Very simple to answer, isn't it? That's why we can say that whenever you are writing, because the common system doesn't have any rule. Common system doesn't have any base, because earlier days they used to decide the name of organic compound on the basis of common system by knowing their sources. But remember one thing, sources is like a failure method, because if somebody is going to ask the name without source, then if somebody is going to ask that what is the answer for this molecule, quickly you'll respond that what is the source of that molecule. That's why we'll say that common system is like a failure method. It is a failure method. It doesn't have any rule. But when we'll go for the IPAC system, we'll see that they are having systematic rules. All these even you have studied in first year. So now you can see that first we'll complete all common method only. After this, we'll go for number of this one, IPAC method. So here this is called as secondary butyl bromide. Why it is called as secondary if somebody is going to ask? We can remember that CH3, CH, CH2, CH3 is secondary. Another point that Br is linked to secondary carbon atom. Br is linked to what? Secondary carbon atom. If Br linked to tertiary carbon atom, then it is called as tertiary. For example, if you are going to take some more examples, we'll take children. Because nomenclature is never ending. Don't think that the nomenclature is very limited. Nomenclature, maybe common system, maybe IPAC system. It is a never-ending process. Because when the functional group change, naming change. When the carbon change, naming are going to change. It means that these are, by changing the functional group, by changing the carbon chain, we can write number of examples. We can write a number of examples. Okay. Now, if as I said that when Br is linked to secondary carbon atom, you have called it as secondary butyl bromide. If Br is linked, don't think that only Br, we can take fluoro also, any of the halide. Okay, this carbon atom, center carbon atom, linked with 3 carbon atom. Carbon containing halide is linked with 3 carbon atom, no hydrogen. As we said in the classification, what we said in the previous class that whenever the carbon is linked all the side with carbon, carbon containing halide is linked with 3 carbon atom but no hydrogen. Those are called as tertiary. That's why 1, 2, 3, 4. How many carbon atoms are there totally? 4. That's why we can call it as what? Tertiary butyl chloride. Tertiary butyl chloride. Tertiary butyl chloride. If instead of this one, if we are going to take, because what I said in the previous class, normal chain, carbon atoms are arranged in open chain, CH3, CH, CH3 is iso, CH3, CH, CH2, CH3 is secondary, CH3, C, CH3, all are branch, nothing, all carbon atoms to the carbon containing halide, it is a tertiary. Whereas, if functional group is present to the next carbon atom, what we can call CH3, CCH3, CH3, CH2. This carbon atom, halide is linked to the carbon which is primary in nature. Halide is linked to the carbon which is primary. But the next carbon atom is what? It is linked with neo. This carbon atom, what is the nature of this carbon atom? 4 side carbon atoms are called as what? Neo. That's why it is called as neo. 1, 2, 3, 4 and 5 pentyl iodide. So in general we are calling what children? alkyl halide. Alkyl halide. That means that whenever we are going to take with respect to the molecule, whenever we are going to take neopentyl iodide, it means that to this one, that is a neocarbon atom, one more primary carbon atom is linked over them. These are called as, that's why I have written over here, this carbon containing halide is primary in nature. This carbon, next carbon atom is neo in nature, because all the four sides they are having what a carbon atom. That's why this carbon atom is called as neo. What is the name? Neopentyl iodide. What we can call it as neopentyl iodide. Same way, instead of all these examples I have taken with respect to what children? I have taken with respect to what a haloalkane. Even some of the examples they have given in the NCERT book, with respect to that also they have given over here. What they have given, even you can take with respect to water, if we are going to take carbon-carbon double bond. If we are going to take carbon-carbon double bond. Yesterday also we said, these are the type where carbon containing halide is sp2 hybridized. These are called as what? Vinyl type. These are called as what? Vinyl. Halide group is chloride. Vinyl chloride. But if the carbon containing halide is sp3, but the next carbon atom is sp2. These are called as what? Allyl. These are called as what? Allyl chloride. Allyl chloride. So in general you can say that this vinyl and allyl is common system. Vinyl allyl is common method, common name. But when we'll go for this one nomenclature, based upon rules only we are going to answer. But this vinyl and allyl, they doesn't have any rule. Only they said that whenever the halide containing carbon is sp2, it is a vinyl. When halide containing carbon is sp3, but the next carbon atom is sp2, these are also called as what? Allyl. Allyl and vinyl. Other than this one, even we have discussed, because our topic is haloarene also. Haloarene, chlorobenzene is common name as well as IUPAC name. But remember one thing, we cannot stop the name of the organic compound with one name, because any functional group, organic compounds are having more than one name. Even we can call it as what? Phenyl chloride. Phenyl chloride. If I am going to take the example, as we are having Cl and CH3. Toluene is what? A parental chain. Even we can write that whenever we are having ortho to each other, means whenever the functional group and the substituent, means main functional group and the next functional group are adjacent to each other. Those are called as what, children? They are ortho to each other. Next carbon atom are meta to each other. Meta, this is ortho. These two are ortho. These two are meta. And opposite one is called as para. Opposite one is called as para. According to which system? Common system. That's why we can call this name as orthochlorotoluene. O-chlorotoluene. O-chlorotoluene. That is orthochlorotoluene. So in a simple way, we can say that whenever we are going to write the name of any molecule, sometimes with respect to the molecule, common system and as well as IUPAC system are same. And remember children, yesterday as I said, whenever there is a geminal dihalide are further classified as geminal and vicinal. Geminal are called as alkylidene. Geminal are called as what? Alkylidene. This is geminal because two halide group are linked to the same carbon atom. These are called as geminal. These are called as what? Geminal. We can call it as what? Ethylidene. Ethylidene chloride. Ethylidene chloride. Whereas if the two halide are linked to adjacent carbon atom, correct? They are called as what? ethylene chloride. Even you can call it as dichloride also. But remember one thing, in the if you go for this one higher classes book, you can see that di is exceptional. That's why I write exceptional case in bracket. That's why what they said that ethylene chloride. If you are going to write ethylene dichloride also, it is not wrong. It is not wrong. That's why we can say that whenever there is a geminal, better to call it as ethylene. Whenever there is a vicinal, we can call it as ethylene. So here, based upon the common system, I have written some of the examples. Let us move to most important part of the topic, that is IUPAC system. Let us move to IUPAC system. Children, you might be remembering that in the first year we have studied rules related with nomenclature. What are the rules? Just will recall. Have you remembered that in the rules we said any organic compound will be divided into 3 parts. What are those parts? Tell me. Root word, prefix and suffix. Root word, prefix and suffix. We know very well that root word is derived from what? Number of carbon atom in a parental chain. Number of carbon atom in a parental chain. Means 1 carbon atom, meth, 2 carbon atom, eth, 3 carbon atom, prop, but, pent, so on. So it means that root word. Prefix means what? Starting name. Prefix is starting name, whereas the suffix is ending name. Suffix is ending name. 1 minute. Suffix is ending name. And in this topic, haloalkane and haloarene, functional group is halide. And halide, they themselves, in the topic name itself, they are mentioned. Halo is prefix. They are mentioned in the topic now. Will you understand? In the topic itself, they have given over here that halo is prefix. Halo is prefix. IUPAC system. I'll recall. So here suffix is ending. Suffix is ending name. But our topic is related with what? Haloalkane and haloarene. Remember here, carbon containing halide. Whenever there is a long chain, you need to give the preference. To the, because topic is haloalkane, singly bounded carbon atom. Singly bounded carbon atom containing halide. Carbon containing halide group must be allotted lowest locant. Locant means what? Where the position, that is the position of X. Position of X, that is the lowest locant. If more than one halide group are repeated, we can call it as ditri, tetra, etc. If they are same, we can call it as ditri, tetra. If they are different, that time we can call on the basis of alphabetical order. Means bromo, chloro, iodo, like that. Based upon alphabetical order, we can do. These are the rules are there. Let us move to the example. We can understand better. Okay, so let us move to the as I have written already with respect to what? CH3, CH2, CH2, CH2. We can call it as what? Carbon atom number 1, 2, 3, 1 chloropropane. 1 chloropropane. 1 chloropropane. If we are going to write, simple way. We'll go for bond line representation also, complete formula also, condensed formula also. Any of this one, because while coming to the second year, while completing this one, because already we have completed the syllabus, you are familiar to represent single bond, double bond, multiple bond, even functional group also. We can call it as CH3, CH, Cl, CH3. This is carbon atom number 1, 2, 3. We can write the IUPAC name as 2-chloropropane. 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 If I am going to write CH3, CCH3, C2H5, what it is? Cl. Longest chain is what, children? Longest chain is this one. 1, 2, 3, 4. Why it is so? Because if I am going in this direction, the chain, the carbon containing halide will be lowest to locate. I need not to repeat, you are familiar with all these. If the second carbon atom we are having chloro group also, substituent methyl also. C will come first than M. That's why better to call it as 2-chloro. Okay? 2-methyl butane. 2-chloro, 2-methyl butane. Same way when we are writing, instead of writing like this, if it is a neo, as I said that neopentyl chloride, carbon containing halide is carbon atom number 1. Second, you go in any direction. 1, 2, 3, 1, 2, 3, 1, 2, 3. Go in any direction, it will be what, children? Containing 3 carbon atoms. First carbon atom are containing chloro group, second carbon atom are containing 2-methyl group. We can call it as 1-chloro. Further, 2,2-dimethyl. Okay? 2,2-dimethyl. How many carbon atom in a parental chain? 3 carbon atom. We can call it as propene. We can call it as what, children? Propene. Isn't it? So we can say that whenever we are going to write, as we said, ethylidene chloride we said. Ethylidene chloride, CH3, CHCl. Ethylidene chloride is common name, but IUPAC name is what? At the first carbon atom we are having 2-chloro. That's why I can call it as 1,1-dichloroethane. 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 Same way if you are going to write the examples, like from the NCERT I have brought some of the examples. If we are going to write, this is Br containing 1 carbon tunnel. Okay, like this if it is the molecule, what to do? Carbon atom number 1, second, third, fourth carbon atom, because we are having 4th carbon atom are linked with Br. Sorry, 1 minute. One more will write that. Because in NCERT they are given 4. That's why we are taking 4. No, this one Br. Okay, 4 carbon atoms are there. Double bond is between second and third. At the 4th carbon atom, we are having what, children? It is linked with Br. It is linked with what? Br. That's why we can call it as what? 4-bromo, but 2e. But 2e. 4-bromo, but 2e. But 2e. If we are going to write, some more examples are there. If we are going to write example like CH3 twice CH, CH2, CH2, Cl. Okay, how to name now? Just we'll expand this one. We'll write the open chain structure. CH. This is CH3 and this is CH3. Correct? Carbon, last carbon atom. This carbon atom containing what? 2-methyl. With this we can write it as CH2, CH2, Cl. Carbon containing halide is lowest to locate. 1, 2, 3, 4. Okay? 1-chloro 3-methyl what? Butane. What we can write here name? 1-chloro 3-methyl butane. 1-chloro 3-methyl butane. In short, I have written because there is no space to write. Just to listen my pronunciation. That 1-chloro 3-methyl propane. 3-methyl propane. Therefore, whenever we are going to write the name, by keeping in mind all the rules, we can go for naming the organic compound. Another examples will write. Some more examples will take with respect to multiple bond also. With respect to multiple bond also will do, children. 1 minute. If a molecule is containing double bond and triple bond both, let us assume if a molecule is containing double bond and triple bond both, correct? Like this. Molecule may be like this, okay? Here we are having what the molecule is containing double bond and the triple bond both. The carbon containing halide is 1, 2, 3, 4. Correct? At the first carbon atom there is a chloro. 1 chloro-bute. Correct? Now, ene and ine both will be present. Ene is for carbon-carbon double bond, ine for carbon-carbon triple bond. Ine for carbon-carbon triple bond. According to alphabetical order, according to the series also, ene will be first, ine will be next. So we can write it as bute, 1 ene, 3 ine. 1 ene, 3 ine. So we can write it as 1 chloro-bute, 1 ene, 3 ine. So whenever we are going to write with respect to multiple bond, it may contain double bond and triple bond both. It may contain double bond and the triple bond both. Sometimes molecule will be very complicated. Okay, for example, let us pick like this molecule is like this. Now, how to name now? It means that I will take another pen. This is one substituent. Correct? This is halide as iode. Carbon chain will go 1, 2, 3, 4 because halide will be preference 1, 2, 3, 4, 5, 6. Total carbon atom 6 are there. At the fourth carbon atom, we are having like this. Correct? Fourth carbon atom, we are having what? Actually, this is tertiary butyl. Tertiary butyl. When the name is unable to identify on the basis of common system, molecule is branched, that time we can write common name even in the IPAC. We can club both. We can club both. Like that example it is. At the fourth carbon atom, we are having what? Tertiary butyl. What? I'll write here. At the fourth carbon atom, we are having tertiary butyl. Because according to alphabetical order, this is butyl and this is iodo. B will come first than I. At the third carbon atom, we are having what? Iodo. How many carbon atom in a chain? 6. XC. Once again, I will repeat the example. At the fourth carbon atom, we are having tertiary butyl. At the fourth carbon atom, we are having tertiary butyl. Correct? At the third carbon atom, we are having I, that is iodo. 1, 2, 3, 4, 5, and 6. The carbon chain is of 6 carbon atom. The parental chain is of 6 carbon atom. At the fourth carbon atom, there is a tertiary butyl. At the third carbon atom, there is a iodo group. Alphabetical order, correct? Alphabetical order like it. This will be butyl and this will be what? Iodo. The alphabetical order, B will come first, I will come next. Fourth carbon atom, tertiary butyl. Third carbon atom, iodo, and the name is hexene. Name is what, children? Hexane. This is a question in NCERT exercise. That's why it said, solve complete exercise. Without solving exercise, you cannot become perfect, children. You cannot become perfect. Another point to that, even yesterday we said, carbon containing halide is sp3 hybridized. Even we can take R-alkyl halide like benzyl, benzal, benzol. How to name them? If I am going, some of the example what I said, common system and IPAC system, naming system are same. Means some of the molecule like benzyl chloride. Benzyl chloride is common name as well as IPAC name. But remember one thing, we cannot end the name with one. Even we can write one more name. Okay. benzyl chloride. Benzyl chloride. But if you'll see one more name, this is the methane, only one carbon atom, containing one side phenyl, one side chloro. Even we can call it as chloro. Okay, phenyl, methane. Benzyl chloride is accepted by both the system. Benzyl chloride name is accepted by both the system. If you are going to write with respect to chlorophenyl methane also, it is not wrong. It is not wrong. In NCERT exercise, one more question is there. Write the impact name of very simple molecule they have given. C2H5 4 times Cl. Sorry, 3 times Cl. So they have given in the NCERT C2H5 3 times only Cl. Like that, we have given the exercise question. Now, while writing this one, always we should write carbon at the center, and 4 side we can write 4 ethyl group. Sorry, 3 ethyl group, 3 side. Correct? Longest chain is what, children? This one. Correct? Yes. Carbon atom number 1, 2. This will be 3, this will be 4 and 5. 4 and 5, because we are having C2H5. At the third carbon atom, we are having chloro group, 3 chloro. Correct? 3 chloro. Now, third carbon atom, we are having ethyl also. The alphabetical order will be 3 ethyl, 3 chloro, pentane. Correct? So here we can say that whenever by knowing the name, by knowing the rules, we can go for naming the compound. Is that it? This is all about some of the examples I have brought for an exercise, but very few examples I have taken from the solved. You too try to solve. Okay? So let us move to isomerism. Next part of the topic is related with isomerism. So whenever we are going to write with respect to this one, children, here we can write with respect to what the alphabetical order we need to follow. Correct? 3 chloro, 3 ethyl. Okay, 3 ethyl. We can write it as what the pentane. Sometimes you get confusion with alphabet also. You see. Okay, let us move to the topic. Isomerism. Okay. I hope all are doing well. Me too. Whether they are going to take offline classes or not. Anyhow, we have completed our syllabus. You need to concentrate on your target. What's our aim? What to do? Anyhow, 2021 exam will be there. Don't worry. Offline classes are there or not, but exam will be there as usual. That's why prepare for theory as well as for all competitive exams. Let us move to next part of the topic, children. Isomerism. Isomerism. Isomerism, which are broad. First, we write broad classification into structural isomerism, and stereoisomerism. Now we are dealing with only with respect to haloalkane and haloarene. We are not at all worried about remaining classification. With respect to haloalkane, like chain isomerism and position isomerism. With respect to what? Haloalkane. Haloalkane. Same way, in stereoisomerism, we are dealing only with optical isomerism. Optical isomerism. Let us move to one by one now. 1 minute. So here, whenever we are dealing with what, children? This one, haloalkane and haloarene. In case of the structural isomerism, we have to discuss two isomerism, that is chain and position isomerism, and in case of stereoisomerism, optical isomerism. Let us move to this one in detail. Let us move to structural isomerism. As we know that even we have studied in the lower class that two or more isomers having same molecular formula, but they are different in structural formula, they are called as isomerism, that is structural isomerism. Now let us see what is chain isomerism. Chain isomerism. Two or more molecules having same molecular formula, but they are having different carbon arrangement. That is, arrangement, name itself indicates that molecular formula is same, but arrangement of carbon chain is different. Example, CH3, CH2, 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 Br. CH2, Br. We can write its isomer as chain isomer. CH3, CH, CH3, CH2, Br. Remember one thing, whenever you are writing chain isomerism, only the arrangement of carbon chain should be different. This is normal and this is what iso. But halide group must be linked to first carbon atom only. Position of halide group should not change. Whenever you are writing chain isomerism, position of functional group should not change. Only the arrangement of carbon chain has to be changed. Now, when we are writing the IUPAC name, if you want to confirm yourself, you can write the IUPAC name as 1-bromo-butane. Correct? Parental chain is butane. This is 1-bromo, 2-methyl propane. 2-methyl what, children? Propane. 2-methyl propane. So here we are taking long chain as 4 carbon atom. Here we are taking parental chain with 3 carbon atom. 3 carbon atom. Either we are taking 4 carbon atom or 3 carbon atom, but the position of halide is same. Position of halide should be same. Even according to the common system, 5 carbon atom, according to common system, 5 carbon atom chain are also called as amide. AMYL. Amide. According to common system, not according to IUPAC system. If according to the chain isomer, if we are going to take CH3, CH2, okay, CH2, CH2, 1, 2, 3, 4, 5, 6, Br. Okay, another halide, Br. This is the carbon atom number 1. I can write it's one more isomer. CH3, CH2, 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 equal picture. Sorry. One, two, three, four, 5. Okay? 5. 5 carbon atom chain will take. CH3, CH2, CH2. Later I'll write 1, 2, 3, 4, 5 Br. But at this carbon atom, we are having methyl. Correct? This is carbon atom number 1. 1, 2, 3, 4, 5, and this carbon atom we are having what? Methyl. First carbon atom only we are having Br. At this carbon atom only we are having Br. If I am going to take one more example like CH3, 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 CH2. 1, 2, 3, 4, 5. Correct? 6. Br. Again the Br is present at first carbon atom. Br is present at first carbon atom. So we can say that whenever you are going to write the chain isomer, only you have to change in the parental chain. This parental chain is what, children? Hexane. 1, 2, 3, 4, 5, 6. Hexane. This parental chain is what? 1, 2, 3, 4, 5. Pentane. This parental chain 1, 2, 3, 4. Butane. So it means that whenever we are writing with respect to chain isomer, the arrangement of carbon chain must be different. But functional group must be linked to first carbon atom. Means carbon atom position, halide group, functional group position must be fixed. It must be fixed. Only we have to change what arrangement of carbon chain. These are called as what? Chain isomerism. Chain isomerism. Next one is position isomerism. Position isomerism. In a structural isomerism, name itself indicates that what kind of isomer. Because isomerism is phenomenon. Isomers are molecules. That's why whenever you are defining isomerism, always you need to say one word that it is the phenomena. Always you need to say one word that it is the phenomena. Because isomerism is a phenomena in which two or more molecules are called as isomers. Molecules are called as what, children? Isomers. Let us move to the second type. Position isomerism. What is position isomerism? Two or more molecules having same molecular formula. Molecular formula is what, children? Molecular formula is same. Let us move to position isomerism. Two or more isomers having same molecular formula, same functional group. Functional group is what in this topic? Halo. Position is same. Sorry. Functional group is same, but position of functional group is different. Same functional group. Different position. Different position. Correct? One chloropropane. One chloropropane. This is 2 chloropropane. 2 chloropropane. Another example we can write with respect to haloarene. 1, 2. Correct? 1, 3. 1, 4. First carbon atom, second carbon atom. First and second carbon atom. First and third carbon atom. First and fourth carbon atom. 1, 2 dichlorobenzene. 1, 2. Dichlorobenzene. This will be what? 1,3 dichlorobenzene. And this will be what? 1,4 dichlorobenzene. That means that whenever we are writing with respect to halide, according to common system, have you remember that? We can call it as ortho. This will be meta and this will be para. This will be para. That's why according to the IPAC system as we are writing 1, 2, 1, 3, 1, 4 dichlorobenzene. 1, 3, 1, 4 and this one dichlorobenzene. One question is there in NCERT. Have you remembered, children? That is 10.1. One exercise question is there in NCERT. 10.1. That example only will solve. Instead of going for our example, better to go with the NCERT example. It is actually a solved example. But remember one thing, don't copy the answer what they have given in the book. And one more thing, whenever you are calculating number of isomer, better to go with IPAC name and no name should be repeated. If no name is repeated, it means that isomers are not repeated. 10.1. Exercise number 10.1. First question. What they have given over there? Draw the structure of all 8 structural isomers having the formula C5H11Br. They have given in the question that they are the C5H11Br. C5H11Br. Already they said that 8 isomers are possible. 8 structural isomers they said. They said already that these are 8 structural isomers. 8 are possible, they said. We need to write their structure. Whenever you are going with respect to this one, first, because 2 structural isomers are possible, chain and as well as position isomer. Let us take 1, 2, 3, 4. 1, 2, 3, 4, 5. This will be Br. Correct? Now, parental chain is what? 1, 2, 3, 4 and 5. Correct? Let us take. Okay. Here we'll keep the Br as it is. We'll keep the Br 1, 2. Carbon atom number 1, 2, 3, 4. We'll keep it as it is. And the second carbon atom will make one branch. It is what? Butane. Correct? Now, first carbon atom Br is there, second carbon atom what? Methyl is there. Instead of taking second carbon atom, we can take this third also. Correct? 1 bromo, 3 methyl. 1 bromo, 3 methyl. Instead of taking 4 carbon atom chain, even we can take with respect to what, children? We can take in such a way that here, this one, that is a halide and this one, both are present on the same carbon atom. Means 3 carbon atom chain. 1, 2, 3. 1, 2, 3, 4 and 5. Correct? 1 minute. Shall I make like this, you see? 1, 2, 3. Correct? 1, 2, 3, 4 and 5. Because we need 5 carbon atom chain. Correct? Now, with respect to this one, first carbon atom, there is a halide. Now, if I am going to write 4 carbon atom chain only, I will take 1, 2, 3, 4. Correct? At the second carbon atom, methyl and Br, if I am going to take to the same carbon atom, is it possible? 2 bromo, 2 methyl. Yes, it is possible. Yes, it is possible. Another one that we can take the 5 carbon atom chain only, but Br we can link to second carbon atom. 1, 2, 3, 4, 5. Correct? This will be Br. Correct? possible? Even we can write Br at the third carbon atom. Correct? 1, 2, 3. Correct? We can write at this carbon atom also. We can write at this carbon atom also. Correct? Even we can write with respect to what, children? At the third carbon atom we have written, even we have written at the second carbon atom, we cannot take at fourth carbon atom. We cannot take at fourth carbon atom. Correct? We can take Br and this one adjacent to each other. Is it possible to take adjacent to each other? Take adjacent to each other is how we can take, children. Is it possible? 1, 2, 3. If the name is repeated or what you see? Because the name should not be repeated, children. 1 minute. 5 carbon atom. Is it possible, you see? If the names are repeated or what means? 1 bromopentane, 1 bromo 2 methyl butane. Shall I write name? If any name is repeated, that time we'll try for one more. Here, 1 bromo, what? 2 methyl butane, 2 methyl butane. One more we can write what, children? 1 bromo 3 methyl. I think this and this 1 bromo 3 methyl. This is 3 methyl. 1 bromo, what? This is repeated. 1 bromo 3 methyl butane. This also you write 1 bromo 2 dimethyl. Correct? Propane. Propane. What we can write? 2 bromo 2 methyl butane. Correct? This will go what, children? For that sake, I am making a box like this. It will be not confusion for you. 2 bromo pentane. 2 bromo pentane. 3 bromo pentane. Correct? 1, 2, 3. Correct? 3 bromo. 1 minute. Carbon containing halide must be lowest. Correct? 1, 2, 3, 4. I think this name is repeated. 2 bromo 3 methyl. Somewhere I have written 2 bromo 3 methyl. No? No way. 2 bromo, no way it is repeated. 2 bromo 3 methyl butane. Anyway, the name is repeated. We'll check once before going to conclusion. 1 bromo pentane, 1 bromo 2 methyl butane, 1 bromo 3 methyl. This is 1 bromo 3 methyl. This is 2 bromo 3 methyl. Correct? 1 bromo 2 dimethyl, then 2 bromo 2 methyl butane, 2 bromo pentane, 3 bromo pentane, and 2 bromo 3 methyl butane. 1, 2, 3, 4, 5, 6, 7, 8. Total how many isomers we have written, children? 8 isomers. 8 isomers we have written. Once you to confirm this one, that whenever we are going to write with respect to 1 bromopentane, 2 bromopentane, yes, we are having 3 bromopentane also, 1 bromo 3 methyl butane, then 2 bromo, 3 methyl, yes. 2 bromo, 2 methyl, yes. Then we are having 1 bromo, 2 methyl butane. 1 bromo, 2 methyl, yes. Second example. Then we are having 1 bromo, 2, 3, 2, 2 dimethyl. 2, 2 dimethyl propane. This also, yeah. Yes. We have written correct. That's why whenever we are going with respect to number of isomer. Number of isomer, because the degree of unsaturation is 0. When you are taking degree of unsaturation as 0, because no double bond or the triple bond over here. That's why whenever we are going to write with respect to the molecule, whenever we are going to write with respect to the any molecule structural isomer, first you try to write all chain isomer. First I have taken chain isomer because I have made one aspect. Because at a time, don't go for writing all, it will be haphazard for you. First, I have written all these examples, then I have made it as position isomer. Like this, we can write. Okay. Now, let us move to stereoisomerism in haloalkane. That is optical isomerism in haloalkane. Optical isomerism. Optical isomerism in haloalkane. I think in the optics you must have studied the difference between what ordinary light and plane polarized light. Ordinary light and plane polarized light. Ordinary light can be converted into plane polarized light by passing through polarizer. And usually polarizer used is Naipaul prism. Usually it is used as Naipaul prism. Optical isomerism. Very important part of the topic. Ordinary light, when it is passes through Naipaul prism, ordinary light, when passed through Naipaul prism, ordinary light, which propagate in all the direction, okay, pass through polarizer, when it is passed through polarizer is usually what, children? Naipaul prism. Usually Naipaul prism. All these you might have studied in the physics related with prism and all. Then it is converted into plane polarized light. Plane polarized light. Remember one thing, plane polarized light is one which moved in single light or monochromatic light. Monochromatic. Chroma means color. Mono means single. Mono means single. Chroma means color. Single color light which propagate in single direction. Which propagate in same direction. Propagate in same direction. Same direction in a simple way. In a single direction. In a single direction. Whenever the ordinary light passes through Naipaul prism, converted to plane polarized light. And this plane polarized light will pass to a polarimeter. When this plane polarized light pass to polarimeter, this is polarimeter. Polarimeter is the instrument which helps to find out specific rotation of a molecule. At what angle particular substance are going to rotate the plane polarized light. And in this polarimeter, we are going to take aqueous solution of sample. Aqueous solution of respective sample. Remember one thing, whenever we are taking aqueous solution of sample over here, all the solution cannot rotate plane polarized light. And the substance in aqueous medium which are capable of rotating plane polarized light, those are called as optically active substances. Listen the sentence properly. Whenever this one ordinary light passes through the polarizer, converted to plane polarized light. And plane polarized light is made to pass through a polarimeter. Polarimeter is the instrument to find out or to calculate the degree of rotation observed by respective molecule. And in that, you might have we have discussed in the theory class that the length of the tube where we are taking the solution must be 10 centimeter. And the concentration must be 1 in such a way that when they are rotating the plane polarized light, all will not rotate plane polarized light. The substance which rotate plane polarized light are called as optically active. Optically active substances are those. Optically active substances are those which rotate plane polarized light. Which rotate plane polarized light. Remember one thing. When they are rotating plane polarized light, either they can rotate in a clockwise direction or they can rotate in an anti-clockwise direction. If they are rotating in a clockwise direction, they are called as dextrorotatory. Have you remembered, children? This dextrorotatory is represented by small d or positive. Don't write capital D and capital L. Capital D and capital L I have said for configuration in hydrocarbons. Sorry, in carbohydrate. Okay. Now, if they are rotating in a clockwise, they are what are dextrorotatory. If they are rotating in an anti-clockwise, they are called as levorotatory. L-A-E-V-O. Levorotatory. L or minus. It means that any substance when they are rotating the plane polarized light either to the positive or to the negative, they are able to rotate. That's why those are called as optically active substances. Optically active substances. Whenever the substance are able to rotate plane polarized light either in a clockwise direction or the anti-clockwise direction, those are called as optically active substances. If they rotate the plane polarized light in a clockwise direction, those are called as dextrorotatory. If they are rotating in an anti-clockwise direction, those are called as levorotatory. Those are called as what, children? Levorotatory. Now, the substance which do not rotate plane polarized light, they are called as optically inactive. Which do not rotate plane polarized light in any direction, kung sa bhi direction. If they are unable to rotate, those are called as what? Optically inactive. जो rotate कर रहा है, those are optically active. जो rotate नहीं कर रहा है, those are optically inactive. Now the question arises that why it is so? On what basis? Some of the substances are able to rotate plane polarized light. Some of the substances are not able to rotate plane polarized light. These are based upon certain conditions. What are those conditions? That we will see together. So what we can say, you might have got the clear picture, partial diagram I have represented, everything we have discussed in the theory class, but to understand the optical activity and all, here I have represented. Remember one thing, whenever we are going to calculate, even we said, whenever we are going to calculate with respect to what, children, whenever we are calculating the specific rotation, whenever we are calculating what a specific rotation, always we can write it as degree of deflection. Okay, how we can write the specific rotation? The specific rotation are represented by alpha, theta divided by c into L. Theta means what? It is the degree of deflection. That is how much angle it can be. Then c represent concentration of a solution. L represent what the length of a tube. Remember one thing. At what angle they are rotating in a clockwise direction, same angle means magnitude will be same. Same angle they are going to rotate in levorotatory. If they are rotating in what angle they are rotating plus, if they are rotating plus 20 degree. In anti-clockwise also they are going to represent minus 20. That's why we'll say, that's why the question arises for neutralization. That is, internal compensation takes place. That is racemization. Taking your, let us move to water. Why does certain compounds are able to rotate flame polarized light? Some are unable to rotate. What is the reason? Reason is that molecule must be, if they are asymmetric. Asymmetric means what? Different. Symmetry means same. Asymmetric means different. If the molecule are containing asymmetric structure, they are able to rotate plane polarized light. They are able to rotate what, children? Plane polarized light. If two colors are there, it will be easy for you to understand. That's why we use different color. But how you are going to take benefit, that we don't know. You need to practice well, children. Without practicing, without going for the synopsis of the questions, you cannot become perfect. Complete synopsis. I hope all the children are referring in CRT. Hope for that everybody is preparing well. Let us move here. What I said? Molecule must contain chirality. Chirality. It is asymmetric carbon atom. Asymmetric carbon atom. Carbon is tetrahedral. Carbon is tetrahedral, and as well as the valency. Valency of carbon, that is a four valency, tetravalency of carbon satisfied by different atoms or molecule. Our topic is related with haloalkane. Let us take the same example. CH3, Cl, H, CH2, CH. This is what? 2-chlorobutane. 2-chlorobutane. Just to observe over here, children, this is the center carbon atom linked with one side methyl, other side ethyl. This is chloride and hydrogen. 2-chlorobutane. This carbon atom is surrounded by 4 different atoms or the molecules. Those are called as achiral carbon atom. Achiral carbon atom. Whenever we are going to take with respect to the tetrahedral in nature, whenever we are going to take with respect to tetrahedral in nature, it's a mirror image. To this, if I am going to take a mirror in between, right will become left. The best example to understand the water optical activity is the right hand and the left hand. Right hand and the left hand are non-superimposable. It means that these are non-superimposable mirror images to each other. This, then we are having Cl, this side we are getting C2H5, and this side we are getting CH3. We can say that these are the enantiomers. Enantiomers. What are enantiomers? Mirror images, non non-superimposable. Mirror images, non-superimposable. Non-superimposable. That's why whenever the molecule are containing chiral center, whenever a molecule is containing chiral center, they are able to rotate plane polarized line. Those are called as optically active substances. They are called as what, children? Optically active substances. Another point that whenever you are going to cut the molecule into exactly two halves by imaginary plane, exactly two halves by imaginary plane, right part and the left part are different. They should not be same. They should not be same. So we can say that plane of symmetry, absence of plane of symmetry. Another condition is absence of plane of symmetry. When a molecule is cut into two exactly halves by imaginary plane, one half should be different from other half. They are called as what, children? They are called as absence of plane of symmetry. That's why whenever you are going to write, with respect to name of the molecule, with respect to identify the optical activity of the molecule, we should know that whether the molecule is containing chiral center or not, or absence of plane of symmetry. Absence of plane of symmetry. Now, one more thing arises that whenever we are dealing with the enantiomerism, what I said that if this is dextrorotatory, this is levorotatory. At what angle, one molecule, that is dextrorotatory molecule, are going to make the specific rotation at the specific rotation in a clockwise direction. Same magnitude is going to take place with levorotatory. That means that equimolar solution of dextrorotatory and levorotatory, those are optically active, converted into optically inactive, called as racemization or racemic mixture. What is racemic mixture? Equimolar. Equimolar means what? Concentration. Equimolar concentration of water. Dextrorotatory and levorotatory. These are also called as DL mixture or plus minus mixture. DL mixture or plus minus mixture. Remember one thing, racemic mixture is optically inactive. Racemic mixture is whatever optically inactive. Actually, this isomerism we are going to study even in nucleophilic. That's why when I will go for the nucleophilic substitution, once again I will stay over there because we are going to deal with carbocation, which is planar in nature. When a molecule is planar in nature, incoming nucleophile can come from the front and as well as from the back. That time we may get a chances of what? How does the front and the back are going to take place? Sometimes it may be a inversion also, sometimes it may be retention also. Remember one thing, whenever we are taking inversion means what? Dextrorotatory sample is converted into levo, or levorotatory sample is converted into dextro. It is called as inversion, ulta, inversion. Whereas if you are going to take with respect to what? Retention. Retention, it means that the optical activity of the sample will be going to remain same. Optical activity of the sample are going to remain the same. Dextro are remaining to dextro, levo are going to remain it as levo only. Okay, all these things even we are going to continue in case of nucleophilic substitution reaction when we are dealing with what? SN1 and SN2 mechanism. The small bit they have mentioned in the syllabus related with what, children? It is related with the nature of CX bond. What is the nature? Because in this one they mentioned even yesterday's class, as I said, carbon with halide. Carbon with halide, that is an open chain hydrocarbon, they are showing a negative inductive effect. When they are showing the negative inductive effect, halide will be acting as a what signal? Halide group will be acting as a what electron withdrawing group. When it is an electron withdrawing group, based on this one, we can identify that based upon the electronegativity, how polar is the bond. Let us move to nature of CX bond. CX bond. The small bit is there. CX bond. CX bond. When we are taking with respect to CX bond, okay, displacement of electron towards X will get a slight negative charge, carbon will get a slight positive charge. What happens to the polarity if X is F, Cl, Br and I? Till tomorrow you think we'll continue the next class. Okay? Prepare well, children. Whatever the example I have taken with respect to isomerism, with respect to naming and all, once you practice, once you prepare well, then only by attending the classes you cannot get benefit at all. Need to prepare. Huh? If any doubt are there, we can post your doubt. Okay, we'll continue the next class, children. Thank you one all.